What you see here looks like a pile of worthless dirty wire. But in the next 10 minutes, this scrap will undergo a brutal transformation to become a masterpiece of cookware worth hundreds of dollars. But be warned, copper is unforgiving. Extreme heat, toxic fumes, and precise timing mean that one single miscalculation, one drop of sweat in the wrong place, can ruin the entire batch instantly. Keep your eyes open for a strange, specific step in the middle of the process. Most people think it's a mistake, but it's actually the secret distinct between useless scrap and culinary perfection. Let's get to work. You think old copper wire is just scrap sitting quietly? Wrong. It's value mixed with hidden contamination. A little moisture, oil, or mud in the wrong bundle can poison everything later. Heavy slag, toxic smoke, porous copper. Today you'll learn why the fight starts with simple things: banding, tagging, and keeping coils off wet ground. One small mistake here doesn't stay small, it travels.
Shipment confirmed. Releasing the barrier.
In copper recycling, the first thing they melt is the truth. A wrong weight or bad record doesn't just change numbers, it changes furnace recipes, QC decisions, cost, and final quality. That's why they photograph every coil, log every detail, and split loads by line. 3 actions. One purpose, traceability. If something fails later, they must know exactly where it began. The most dangerous things are the ones you don't notice. Batteries, spray cans, small gas cylinders, capacitor parts, tiny bombs inside a scrap load. One jam, one spark, and the line stops. Or worse. Before speed, they set safety, PPE, clear zones, machine spacing, and one warning sign matters more than people think. Strong chemical smell. That's not just dirty, that's risk. Copper isn't just copper. Bare wire, thick PVC, thin insulation, multi-core with shielding, each behaves differently in the machines. Sort wrong. And you don't just lose efficiency, you create a contaminated melt. This is where human judgment beats automation. Inspecting structure, cutting off heavily caked sections, removing steel fittings, sampling copper to plastic ratio. One label, grade ABC, decides the entire path. Remove plastic, keep copper. Sounds easy, until one wrong blade setting turns copper into fines and plastic into sticky fragments. Thick wires get stripping, small multi-core goes to granulation. The critical point is the cutter gap. Too wide, plastic stays. Too tight, copper gets shredded. They check cleanliness fast. If copper carries insulation beyond the limit, it goes back. No excuses. Now the metal starts to roar. Cutters chop, shredders tear, granulators size it down, but the goal isn't make it small, it's make it uniform, clean, and melt ready. Sensors fight jams, magnets pull out iron, air classifiers push out light plastic. Then wash, dewater, centrifuge dry, hot air dry. And there's a quiet loop nobody wants, rework. If it's not clean, it returns. The real enemies are microscopic, fine iron, hard steel bits, hidden aluminium. You may not see them, but they ruin surfaces and create defects that feel mysterious later. So they run a second strong magnet, then metal detection, then eddy current to kick out aluminium. Final sizing sends good granules to silo, off-size back to rework. Then they seal everything because contamination can return in seconds.
Processes you see clean and safe? Yes, comment 4. No, comment 5.
Hold position, copper pot 621. Wait for clearance.
A copper furnace doesn't forgive rushing. Charge too fast, too wet, or in the wrong order, and you get violent smoke, oxidation, and slag overflow. They build a stable hot bath first with clean, larger copper. Only then they feed granules slowly. Flux isn't extra. It's the tool that gathers impurities and floats them into slag. Watch the surface, color, foam, movement. One bad slag skimming moment can drag impurity right back down.
Temperature holding steady at 1200.
Acknowledged. The soak is proceeding as expected.
Control, this is Charlie at the ladle stand. Thermal scan is good, ready for the charge.
Molten copper can look perfect and still be full of gas. They take a sample, let it freeze, and read the defects: pores, roughness, color signs. Then comes deoxidation, critical for preventing voids during casting. They manage surface cover, skim fine slag again, hold settling time so heavy dirt sinks and light slag rises. Right before pouring, they skim one last time. Miss it, and the whole melt carries scars.
We are approaching target weight.
Acknowledged. Preparing to tilt back.
Molten metal meets water and it doesn't sizzle. It explodes. That's why the casting floor must be dry, molds must be clean, preheated, coated, numbered for traceability. Pour too slow or stop-start and you create cold shuts, weak layers inside the ingot. They pour a small primer, stabilize flow, top up for shrinkage, and cool under control. Then stamp the ingot with batch identity, no hiding.
It's completely dry. Drainage is clear. We're ready.
Roger that. Crane, we are clear.
Maintain flow rate.
Clear.
Ingots don't become sheets by magic. Reheat too low, edges crack. Too high, oxide grows thick and ruins surface. Rough rolling hits hard, then pass after pass controls thickness without tearing. When the sheet work hardens, they anneal to restore ductility. The final checks are brutal. Thickness, flatness, surface quality. Because if the sheet is wrong, the giant pot will warp later. A beautiful sheet can be ruined by one ugly cut. Burrs and rough edges don't stay at the edge. They scratch dies, tear during deep drawing, and leave permanent scars. So they mark diameter and center, choose the right cutting method, cut clean, deburr carefully, protect surfaces in stacked batches. Center marking matters. If the blank is off center, the pot will never be truly round. This is where copper becomes a vessel. They clean the blank, apply proper lubricant, clamp with correct force, draw once, check wrinkles, draw deeper, risk cracks. If the metal hardens too quickly, they anneal between draws, then spinning or forming refines the shape, rounds the mound, and fixes symmetry. The key test is thickness mapping, rim, wall, base. Thin spots are silent failures waiting to happen.
Lower it slowly, watch the edge. That looks perfect, shut it down.
A giant pot must be safe, stable, and strong. They roll the rim so it won't cut hands. They flatten the base so it stands solid and heats evenly. Handle holes are jig positioned, no guesswork, then riveted and pull tested. Every sharp ridge is ground smooth. Polishing isn't vanity, it's surface discipline. Then they degrease and wipe down because leftover compound can fail QC instantly. After all that fire and force, a pot can still fail on small things. Warp, leak, rough patch, uneven base. QC is the final court. Then they laser the logo and batch code, traceability on the product itself. They wrap against scratches, box, palletize, warehouse, ship, and display. When a customer touches that cool copper surface, they're touching a chain of decisions that had no room for error. At the end of this journey, one lesson stands above everything else. Copper is never just melted. Quality is decided long before the furnace in sorting, cleaning, patience, and control. Every shortcut leaves a fingerprint. Every small mistake survives the fire and shows up in the final product. This process proves a simple truth. Precision is not an extra cost, it is the product itself. When copper is treated with discipline, it rewards you with strength, purity, and longevity. When it isn't, no polishing can hide the flaws. In recycling, as in life, what you allow at the beginning decides what you live with at the end.
Thank you for watching the video. Please subscribe to my channel. And what production process would you like to see next?